Good afternoon, everyone, and welcome to this seminar. My name is Fabio. Today I'm presenting my major project about the instrumented rig test station for sail evaluation. I have received this model boat from my former, the mono hull, fitted with conventional sail on it, and this boat has been used before for autonomous navigation and other projects, but it has failed because of the type of this sail. It's been requested for me to design and build winged sail, which is a rigid sail. Find a way to adapt one and the other on the same hull for evaluation purpose, and also to do that, design and build a rig station to take measurements from it. So the concepts behind this project basically is the concepts of sailing, so a good understanding of the boat positioning against the wind direction. So on this 0 hour here we have a no-go zone, so that means the boat will never go through the wind itself. It will be always having a resultant force going sideways. So if it's going upwind direction, we have two positions, and then all the which depends on lift from the sail to be going forward. Otherwise, the most of them going with the wind will be going using more drag than lift itself, or a combination between them. If it's going upward wind, it will have to be going a zigzag trajectory because of this angle here. It has to use tacking positions to reach destination ahead. Thanks to Bernoulli's theory, with his Venturi experience, he dealt to aerodynamics concept, where the differential pressure in one side of the airfoil and the other cause this lift effect. Okay. So in the literature, I have found few examples for winged sail. Some of them only use a symmetric airfoil, causing some, getting some small angles from the wind direction. It might get some lift. Some of them already I can see using autonomous navigation, use just a little trimmer on the back of the wing sail to get it better result. Some of these designs use a big trimmer area with a folding mechanism coming back from the sail, the symmetric sail. And also I added here a trimaran model, which used 3 hulls with one wing sail. This kind of model here is one of the winners in the competition at these days. It's considered the fastest ones. This is my first approach, my first prototype for wings, rigid wing. I used some ribs to make this airfoil with a folding trimmer, getting the full length of the back on the trailing edge of this airfoil. Unfortunately, after I tested on the boat, it was a little bit overweight, causing the boat to heel over. And also I learned from this that the mast position should be centered to this airfoil, otherwise when it turns it causes the boat to be unbalanced, as most of the weight would be more on one side than the other. So this kind of airfoil is called NACA 0012. This is my second prototype where I corrected this position of the mast, and I used a lighter material, the foam board 3 millimeters. With you can see inside here is a long balsa wood, which is a very light material as well to give strength for the whole length. This wing here has about 1 meter span by half meter cord. The way I found to adapt this in a light way is a clip-on section, so easy to remove and replace for another one. For the conventional sail, I've got to print the whole the full length of the boat deck to attach the strings that come from the top of the mast on the 4 positions, and made 2 openings here for the control strings come to the front and back sail. To adapt this for my wing sail, I initially done a double deck platform. However, after I realized about the weight restriction on the first wing, I changed this for a single platform, taking the mast straight inside on its original place here. That was much lighter. My rig station is a frame where I can sit the boat inside in a free movement swing. And on the back of this platform here, I attached a load cell to measure the force forward. And also this whole frame is rotating on a center pin with this template on the floor where I can simulate the positions that I've shown at the beginning of the presentation. So I can simulate these positions separately. At the front of this rig station, I have added an anemometer, so I can measure the wind speed as well. And on this one, I've got to develop a mechanism here to attach this sensor, because this sensor here only measures one forward movement, and this platform here is supposedly to be shaking sideways as well. So it's likely we can see how it moves. If I attach the sensor directly, it will break the sensor. I have recently started testing these sails, and on a closed hull position, I have the conventional sail here showing this comes from 0 to 100 grams amplitude. 0 towards the positive values means lift, so if otherwise it would be only drag. And from the conventional sail to the rigid sail, you can see now the rigid sail that I've done, it has shown some point here, 100% efficiency than the actual conventional sail. So it's showing that it's much better to use a conventional wing sail for autonomous navigation. So in this way, I can summarize that wing sail can have a free rotation design. There is no strings, no tangles, and no shift sail positioning, which was happening with the original sail. Depending on the position the boat was, the sail started flapping one side to the other and couldn't go anywhere. So on the rigid sail, we wouldn't have this problem. And the rigid sail is only dependent on the wind direction reference, which would be very easy to identify and get results from that.